Hello, welcome to a video about change of state. Matter commonly exists in three states: solid, liquid and gas. To change a solid to a liquid, which is called melting or fusion, and to change a liquid to a gas, which is called boiling or vaporization, requires the input of energy. Some substances change from solid to gas, which is called sublimation, or from gas to solid, which is called deposition, without going through a liquid phase. In stage 1 physics, the expectation is that you'll be able to explain the difference between evaporation and boiling using the particle model. So I've got a table here. Probably this is just going to be revision, but it's just looking at the particle properties, particle structure and physical properties of the three different states. So for solids, particles are tightly packed in an irregular arrangement, and as we've discussed earlier in this unit, their particles vibrate around a fixed position. Their structure is pretty regular and organised, and their physical properties are that they have a fixed volume, a fixed shape, they can't be compressed, and their material can't flow because it's in that fixed shape. For a liquid, their particles are close together, but there's no regular arrangement, and the particles can vibrate, rotate, translocate around the material volume. They also have a fixed volume. They adopt the shape of their container, so if you pour liquid into a container of some description, the liquid will fill the container in all of the container's crevices. Liquids can be compressed, and liquids can obviously flow. For gases, their particles are far apart, there's no regular arrangement, and they are also free to translocate around the material volume. Gases don't have any fixed volume or shape, they can be compressed, and the material can also flow, so gases can also flow. So the state of matter may change upon energy addition or removal. For energy being added, this would include solids going to liquid form, so this would be melting. It also includes liquids going to gas form, this is boiling or vaporization. And if solids go directly to gas form, this is called sublimation. If energy is removed, this includes liquids transforming into solids, and this is called freezing or fusion. Gases going into liquids is called condensation, and gases going directly to solids without going via liquids is called deposition. A lot of this is probably revision from earlier science, but it's just a recap so that you're able to explain these processes in terms of the particle model. So with melting and freezing, melting occurs when a temperature of material increases to its melting point due to heat addition. The regular particle arrangement becomes broken down, particles separate, and the material transitions into its liquid state. With freezing, this occurs when the temperature of a material decreases to a freezing point, and this is due to heat removal. Freezing point is generally the same temperature as melting point, it's just the opposite direction of heat addition. So with melting, heat is being added to the material, with freezing, heat is being removed from the material. So with boiling and condensation, boiling, also called vaporization, occurs when the temperature of a material increases to boiling point due to heat addition. Particles of the substance separate and the substance overall transitions into a gaseous state. Condensation occurs when the temperature of a material decreases to boiling point due to heat removal. Particles are moved closer together and the transition into liquid state occurs. So the point at which both of these occur is boiling point, but again, like melting and freezing, the direction of heat addition or removal is different. So with boiling, heat is being added, with condensation, heat is being removed. The boiling point is just the threshold between liquid and gas. So we'll move on to evaporation. The average kinetic energy of a substance increases when heat is transferred to a liquid. Particles with higher kinetic energy near the surface of whatever liquid may have sufficient kinetic energy to enter the gaseous phase. The energy is therefore removed as particles with a high amount of kinetic energy evaporate. Energy is therefore removed as particles with lots of kinetic energy evaporate, because thermal energy includes kinetic energy. So if that energy is being removed, then the thermal energy is going to decrease. If thermal energy decreases, this therefore results in a decrease in temperature. Evaporation can occur at any temperature. It doesn't have to be boiling point for it to occur. This photo here, I didn't take it, but it's of Lake Mývatn, which is in Iceland, and you can swim in the geothermal pool there, which is pretty nice. You can see that evaporation definitely is occurring there, but if you can swim in it, it's probably not 100 degrees, so evaporation can occur at any temperature. Sweat is an example of evaporation, a practical application or a practical function of it. Sweat evaporates from our skin surface because of body heat, so our body warms up the sweat and then that sweat evaporates. When it evaporates, thermal energy is removed because the particles within the sweat that have higher kinetic energy transition into gaseous phase, so our body temperature is reduced. So the sweat that drips off your body won't cool you down, but it needs to evaporate in order to remove that thermal energy from your body. So boiling and evaporation are related, but they're not identical. So boiling occurs at boiling point, whereas evaporation can happen at any temperature. Boiling occurs throughout a liquid's volume, whereas evaporation only occurs on the surface. The temperature remains constant when liquid is boiling, but the temperature decreases following evaporation. And finally, sublimation and deposition. Sublimation is a transition of solid to gas without passing through a liquid state. An example of this is snow transitioning directly to water vapour. Deposition is a transition of gas to a solid without passing through the liquid state, so it's just the opposite direction to sublimation. This photo here shows some water vapour that has formed solid ice crystals on some leaves of a plant.